I am Dennis Morales from SLI IT, student ID MS 19808826. This is my assignment 2 on wireless network technologies. We'll straight jump to the slides. At the first point, we'll talk about the different versions of IEEE 802.11. In IEEE 802.11 standard and features, we'll first to talk about 802.11. Its frequency range is up to 2.4 GHz and speed 1 to 2 Mbps. Transmission range is 20 feet. And the next 802.11, its frequency range is 5 GHz and speed up to 54 Mbps. Transmission range to 25 to 75 feet. And then version is 802.11b. Its frequency range is 2.4 GHz and speed up to 11 Mbps. Transmission range is up to 150 feet. And then 802.11g, its transmission range, its frequency range to 2.4 GHz and speed up to 54 Mbps, and transmission range is up to 150 feet. And then finally its 802.11n, its frequency range can be set as 2.4 GHz or 5 GHz, and its speed is up to 600 Mbps. Transmission range can be go 175 plus transmission range feet. And this transmission range can be affected by the interference in the buildings. We'll talk about the IEEE 802.11 architecture. There are two kinds of services that explain the standard: the basic service set and the extended service set. First, we'll see the basic service set. IEEE 802.11 defines the basic service set as the block of wireless LAN. A basic service set is made of mobile wireless stations and an optional central base station known as the AP. It means as access points. And we'll move on to the extended service set. In this service set, consisting of a set of basic service sets, must have a common SSID. The BSS can work on the same or different channels, that means wireless channels. This basically helps to boost the signal throughout the wireless network. A signal service set consists of all STAs receiving signals from a given AP and creates an 802.11 wireless LAN. Each STA may receive a signal from several APs within the range. Depending on its configuration, each STA can manually or automatically select the network with which to associate, and multiple APs may share the same SSID as part of the extended service set. Although not part of the 802.11 standard, some wireless APs may broadcast multiple SSIDs. And then we'll talk about the MAC layer of IEEE 802.11 and also the framework. One of the two protocol defined by IEEE at the MAC sublayer is called as the distributed coordination function. In this distribution coordination function, uses CSMA-CA as the access method. Wireless LAN cannot implement CSMA-CD for below 3 reasons. For collision detection, a station must be able to send the data and receive collision signals at the same time. This can mean costly stations and increased bandwidth requirements. Collision may not be detected because of the hidden station problems. The distance between stations can be great. Signal fading could prevent a signal at one end from hearing a collision at the other end. Now this is the time to talk about the hidden and exposed station problems. First, we'll look at the hidden station problem. In this diagram, according to this diagram, station B has a transmission range shown by the left oval, a transmission range shown by the right oval. Every station located in this range can hear any signal transmitted by station C. Station C is outside the transmission range of B. Likewise, station B is outside the transmission range of C. Station A, however, is in the area covered by both band C. It can hear any signal transmission by B or C. Every station in the range can hear any signal transmitted by station B. Assume that station B is sending data to station A. In this middle transmission, station C also has data to send to station A. However, station B is out of B's range, station C is out of B's range, and transmission from B cannot reach C. Therefore, C thinks the medium is free. Station C sends its data to A, which results in a collision at A because this station is receiving data from both B and C. In this case, we say the station B and C are hidden from each other with respect to A. Hidden stations can reduce capacity of the network because of the possibility of collision. The collision to the hidden station problem is the use of the handshake frames, that means RTS and CTS, that we discussed earlier. Because both B and C are within the range of A, the CTS message which contains the duration of the data transmission from B and A reaches C. Station C knows that some hidden station is using the channel from transmitting until that duration is over. And then we'll see about exposed station problem. The handshaking messages RTS and CTS cannot help in this case, despite what you might think. Station C hears the RTS from A but does not hear CTS from B. Station C, after hearing RTS from A, can wait for a time so that the CTS from B reaches A. It then sends an RTS to D to show that it needs to communicate with D. Both stations B and A may hear this RTS, but station A is in the sending state, not the receiving state. Station B, however, responds with CTS. The problem is here. If station A has stopped sending its data, station C cannot hear the CTS from station D because of the collision. It cannot send its data to D. It remains exposed until A finishes sending its data. Now we'll explain the IEEE 802.11 physical layer feature. The initial 802.11 standard defines two forms of spread spectrum modulation. For the physical layer frequency hopping and direct sequence, these two standards specify a 2.4 GHz operating frequency with data rates of 1 and 2 Mbps. Another initial physical layer utilizes infrared passive reflection techniques and transmission of data at 1 and 2 Mbps. However, this standard has not been implemented in products. Most companies implementing wireless LAN today are installing 802.11b based systems. The 802.11d SSS radios incorporate with 802.11b access points. However, the 802.11 FHSS radios do not help for this. Now we'll explain the Bluetooth architecture, layer and frame form. Bluetooth is a wireless technology designed to connect devices of different functions such as telephones, notebooks, computers, laptop or desktop computers, that's fine, cameras and so on. A Bluetooth LAN is an ad hoc network, which means that the network is formed spontaneously. The devices, sometimes called the gadgets, find each other and make a network called Piconet. Bluetooth technologies has several applications. Peripheral devices such as wireless mouse or keyboard can communicate with other computers through Bluetooth technologies. Monitoring devices can communicate with the sensors, with the sensor devices in a small healthcare center. Home security devices can use this technology to connect different sensors to the main security controller. Conference attendees can synchronize their laptops, computers at the conference, and so on. Technology is used so far, and so many Indian industries based on using Bluetooth technologies. And we'll come to the architecture. Bluetooth defines two types of network. One is Piconet, and the other one is scatternet. First, we move on to the Piconet. A Bluetooth network is called a Piconet or small net. A network of a Piconet can have up to 8 stations, one of which is called primary, the rest are called secondary. All the secondary stations synchronize their clocks and in sequence with the primary. Note that Piconet have only one primary station. The communications between primary and secondary can be one-to-one or one-to-many. Then we will move on to scatternet. The Piconets can be combined to form what is called scatternet. A secondary station in one Piconet can be primary and other Piconet with the primary in the other Piconet. This station can receive messages from the primary in the first Piconet and acting as a primary deliver them to secondary in the second Piconet. A station can be a member of two Piconets. And now Bluetooth layers. If we see in this diagram, Bluetooth uses several layers that do not exactly match those of the internet model. One is radio layer and the other one is baseband layer. The radio layer is wrongly equivalent to the physical layer of the internet model. Bluetooth devices are low power and have a range of just 10 meters. And we'll move on to the baseband layer. The baseband layer is roughly equivalent to the MAC sublayer. In LANs, the access method is TDMA. The primary and secondary communicate with each other using time slots. The length of a time slot is exactly same as the dwell time. This means during the time that one frequency is used, a sender sends a frame to a secondary or a secondary sends a frame to primary. Note that the communication is only between the primary and a secondary. Secondary cannot communicate directly with one another. Alright, and now we'll move on to the frame format. In the frame format, a frame in the baseband layer can be one of 3 types: 1 slot, 3 slot, or 5 slot. Even though only 1 hop number is used, 3 hop numbers are consumed. That means the hop numbers of each frame is equal to the first slot of the frame. And now we'll change the slide to design your wireless net. When we plan a design to a network, there should be a proper plan or strategy. So basically there are 4 steps to do that. In here you can see that 4 steps: requirements gathering, plan and site designing, configuring and installation, and first test and validating. First we'll see what is the basic steps and briefly explain that. Requirements gathering. Firstly, IT departments will conduct a meeting with the higher management in order to understand the business requirements to plan and access points and wireless network. As the first step, it is involving collecting site survey questionnaires and floor plans information. Finally, this data will be evaluated and documented. Okay, planning and site designing means Wi-Fi network planning mostly done using heat maps. All right. In this segment, the predictive site survey software tool will be used. This involves with access point on a stick, that means APOS survey. This survey conducted to test the radio frequency properties and characteristics of the particular location. Afterwards, its estimation of the number of access points will be decided. Depending on the number of APs, the budget will be decided. As the last step, Wi-Fi design report will be submitted to the top management of stakeholders. And then configuration and installation. In this step, the required materials will be installed to implement the Wi-Fi network. The configuration cost will be made depending on the environment and the business needs. such as cabling, switch configuration will be configured. Okay, and for first testing and validating, this is the most important part. This involves with implementation of wireless network in real environment, and just test whether it's working fine or not. And then we'll move on to Wi-Fi channels. In the Wi-Fi channels, there are two Wi-Fi channels, basically to 2.4 gigahertz and 5 gigahertz. These frequency band carries out through the radio waves. Most of the wireless devices, wireless routers uses 2.4 gigahertz frequency bands, but there are some dual band routers which can be transmit to 2.4 gigahertz and 5 gigahertz. 2.4 gigahertz frequency band is the IEEE 802.11 standard, and also it will work pretty well, but this same frequency band is using in more devices such as codeless phones, Bluetooth, microwave oven, and so on. Because of many devices using the same band, the signal will get low, or it might leads to signal loss due to interference. Alright, and we'll move on to just explain the 5 gigahertz band. 5 gigahertz band used only with some devices, so it will stay as strong signal, and this 5 gigahertz band will give high speed internet because of its high frequency transmission, and also it's due to minimal interference. And if we come to the non-interference channel, 2.4 gigahertz is more vulnerable to interference is because of the difference in the wireless channels. If you feel the signal drop in 2.4 gigahertz band, then you need to change the wireless channel and see. Okay, there are 11 channels in 2.4 gigahertz band, but it has only 3 overlapping non-overlapping channels. They are 1, 6 and 11 channels. If we take 5 gigahertz frequency band, there are more channels, and 25 non-overlapping channels are there to access. And then in the next slide, if we talk about the advantages and disadvantages, 2.4 and 5 gigahertz advantages are 2.4 gigahertz maximum range of coverage, can penetrate solid object better, and 5 gigahertz high speed data transfer and less vulnerable to interference. This is mainly as 2.4 gigahertz, because of the frequency range is low, it will basically can travel up to the second floor. If we set an access point with 2.4 gigahertz in the first floor, it can be accessed from the second floor as well. But 5 gigahertz you can't access from the second floor, only the first floor can be accessed. Disadvantages is of opposite of advantages. 2.4 is vulnerable to interface and lower in speed. 5 gigahertz smaller range of coverage and hard time to pretending solid object. And then how to set up a wireless router. In this case, nowadays routers come with clearly labeled ports, making it simple for you users to connect everything. Most houses have basic configuration preset at the factory. We are not able to do that in normal uses. If you have a router, you need to get it connected and online. If the service provider gave you a modem when they enable your internet service, this should be simple. Just follow the following steps. To turn off your modem, unplug the modem's Ethernet cable from the PC, connect that cable to the WAN or internet port on your new router, power on your modem, next power on your router. You now use another Ethernet cable to connect the PC to your router's LAN port and turn on PC. I just read it out for more information. Okay, with your network now properly configured, you can move on the setting up the wireless network. This is actually very simple and should only take you a couple of minutes. When you do this, make sure your use of computer is connected to the network via the Ethernet cable, not in the wireless. Don't try to connect with the wireless. And the wireless controller. Next we'll move on to wireless controller. Wi-Fi controller is a centralized Wi-Fi management system. It will help to manage all access points. Following are the function that explains why a Wi-Fi controller needed in a network. Centralized authentication. Nowadays wireless communication improved in security aspect. Instead in inserting MAC address one by one to the access points. Controller provides for centralized authentication mechanism through individual username and password based on Active Directory. You can see this in this diagram. Interference mitigation, manageable access points are always designed in the work in the different non-overlapping channels through the controller so that packets will not lost due to interference in a wireless network. And we'll move to load balancing. In the sense of load balancing, users are automatically shifted to adjacent access points. If a particular access point is overloaded, the Wi-Fi controller can shift the users without any loading issue to the another access point, another available access point. This is called as load balancing. And we'll move on to RFID system. It is the technology. It is a technology which is working based on radio frequency waves. This is basically used for to automatically identify the objects or track the objects. Moreover, the RFID tag need to be attached with the object, and the RFID reader continuously send the radio frequency waves. Since this is not a line of sight technology, when the RFID tag attached object comes within the RFID reader's range, the tag is able to identify the reader and send the information back to RFID reader. Now we'll see the features of the RFID. RFID system contains of two components, RFID reader and RFID tags. RFID tags mainly, there are three tags. One is active tag, another one is passive tag, another one is semi-passive tag. If we see the active tag, these type of tags have its own power supply. Moreover, the same power supply, the power source will be used to transmit the feedback signal to the RFID reader. And then passive tag. Passive tag is basically this type do not have its own power supply. So these are working with the radio waves which is generated by the RFID reader for the source of power. And then semi-passive tag. These kind of tags have its own power supply, but in the case of sending feedback signal to the reader, it will relay in the radio waves which was generated by the RFID reader. And then we'll move on to the RFID reader. There are three components in the RFID reader: radio frequency signal generator, a microcontroller, and a signal receiver. This RFID reader is a normal thing which we see in our day-to-day life in the shopping malls, and also can be handled readers in the in any other shapes like supermarkets and other small devices also can now identified as RFID readers. Now we'll see how it works. The signal generator generates the radio waves via an antenna. Also, the signal receiver will receive the feedback signal which is coming from the RFID tag. In order to process the signal, the RFID reader have a microcontroller. These RFID readers are connected to computer. Right? Then RFID tag. RFID tags could be many shapes. Mostly RFID tags are passive tags because it's much cheaper in price comparing to the active and passive semi-passive tags. Also, due to no power source, it's quite compact tag and easy to use. There are some components of RFID tag: transponder, rectifier circuit, controller, and memory. Let's see how it works. The transponder, which receives the radio signals from the reader and sends the feedback signal back to the reader via an antenna. Since the passive tag do not have a power supply, it will store the energy which is coming from the RFID reader and do the process of controlling and memory. RFID use applications are library systems, hospitals, schools, transportation and logistics also nowadays using the RFID system. And also it can be used in companies as access control and also used to track the animals. You can see the diagram of frequency lengths of RFID that works: low frequency, high frequency, and ultra high frequency, and the length and the speed are there. Now we'll move on to the Bluetooth. This is known as the wireless personal area network. Bluetooth standardized with IEEE 802.15.1 and is basically low in cost and power consumption and small in size. This Bluetooth technology is designed to work in the 10-meter range with a stable connection. It is mostly used in mobile phones and IoT devices. And then Zigbee. The Zigbee is basically known as a mesh network protocol. This technology uses low power consumption and it can be accessed 100 feet in no obstacles. It is mostly used in wireless sensor networks. Zigbee technology standardized with IEEE 802.15.4. And hotspot. Nowadays hotspot are widely used technologies. We can use this hotspot through our mobile phones using built-in wireless transmitter. Most of the hotspots are standardized with IEEE 802.11. And then we'll to talk about the Li-Fi. As a Li-Fi, this is called light fidelity. The basic idea of a Li-Fi technology is data is transmitted using visible light source. As we know, the Wi-Fi is using radio waves to transmit the data. Normally, the LED lights which are used at our homes can be used for a Li-Fi. Let's see how it works. A light bulb brightness always depends on the current flow it's get. If we change the current level of power supply which is flowing in the particular LED bulb, it will eliminate the brightness or change the brightness. This is the simple working principle used in Li-Fi. If there is minimum source of power supply, current flows on LED bulb in the brightness will be minimum. So this treated as digital 0, and it will transmit at the receiver side. On the other hand, if light is on or maximum power is flowing to the LED light bulb, it will treat as digital 1, and it will transmit it to the receiver side. As like that, by flickering the light, we can transmit ones and zeros to the receiver end. This flickering happens in milliseconds, so we cannot see in our naked eyes. In order to receive the data from LED, we need to have the Li-Fi dongle, which is consist of a photo receiver and IR transmitter. These Li-Fi dongles are made by Pure Li-Fi company, and we'll see some the advantages of Li-Fi technology. Its more speed. Researchers achieved a maximum speed of 10 gigabytes in a lab scale prototype. Security is high. That means nobody can hack without your concentration, without your knowledge. Safety, full safety is there, and congestion free. Applications of Li-Fi. This Li-Fi technology can be used in patient monitoring in the hospital, since it is provided high speed internet. Vehicles can communicate with other vehicles using this Li-Fi technologies through front and rear lights. It can be also used in underwater. In future, it can be used in street lights and provide the high-speed internet to Li-Fi in the street lights. And then we'll come on to wireless sensor network. A wireless sensor network can be categorized as a network of devices that can be communicate data accumulated from a monitored area through wireless connections. The data is sent through various nodes and within a gateway. The data is associated with the other networks. WSN, that means wireless sensor network, is wireless network that compares of base stations and quantities of nodes. These networks are monitored physical or natural natural conditions like sound, weight, temperature, and everything. The types of wireless networks are they are in underwater, in underground, multimedia, mobile, WSN. Limitations of wireless sensor networks are consumes very little storage capacity, having simple processing power, can be worked in short range of communication, needed minimal energy, batteries with limited size of lifetime, passive devices provided little energy. Advantages of the WSN means network setups can be completed without fixed infrastructure, appropriate of the non-reachable places, adaptable if there is any random circumstances with extra workstation is required, usage valuing is cheap, it avoids a lot of wiring, it may oblige new devices whenever it is adaptable, so experience physical partitions. And we'll move on to the difference of WEP, WPA, WPA2 wireless security protocols. When it comes to wireless network, they are vulnerable attacks. So securing your Wi-Fi network with a password is first. We'll explain it one by one. WEP, a security protocol for wireless networks introduced in 1999 in order to provide the data confidentially comparable to a wired network. Through the use of security algorithm of IEEE 802.11 wireless networks, it works to create a wireless network that is as secure as the wired network. Wireless security through the use of an encryption key, open systems authentication, and shared key authentication. WPA, a security protocol developed in the Wi-Fi Alliance in 2003 for use in securing wireless networks, designed to replace the WEP protocol. As a temporary solution to WEP's problems, WPA still uses WEP's insecure RC4 stream cipher, but provides extra security through TKIP, wireless security through the use of password, authentication through use of the 64-digit hexadecimal key or 8 to 63 character passcode. WPA2. This is the successor of the WPA convention. WPA2 has replaced WPA and WPA2, which is required testing and certified by the Wi-Fi Alliance, actualize the compulsory components of IEEE 802.11i. Specifically, it incorporates obligatory help for CCMP as AES based encryption mode. WPA2 for affirmation is compulsory for every single new devices to hold up and under the Wi-Fi. And then we'll move on to MIMO antenna functions and characteristics. MIMO antenna means multiple input and multiple output. It is called MIMO antennas. This is the one of the possible solution to have more reliable communication with high data rates, to have multiple antennas in the transmitter and in the receiver end. This framework is called as MIMO. To today's technological world, MIMO is incorporated in the most of the wireless routers standardized IEEE 802.11n in 4x4 antennas and in LTE 4G mobiles. In the future, MIMO will be the important part of wireless network technologies. This MIMO system is able to deliver high data rates in high reliability. There are many advanced techniques developed for this MIMO antenna purpose. Following are the basic techniques of MIMO: beamforming and multiplexing. We'll first see about the beamforming. The transmitter focuses narrow signal beams in the direction of the receiver, thus enhancing the signal reliability. Beamforming requires that the transmitter knows the wireless channel. And then multiplexing. In multiplexing, the transmitter increases the effective data rate by sending parallel streams of the data on the different antennas at the same time. You can see it in both the diagrams and get some more ideas about this. And thank you so much.